All right. Thank you all for being willing to listen to me for a half an hour, but I'm very grateful to be able to speak with you about ANARI. And there's a lot that could be talked about with an API standard, especially if you're coming in cold. So my hope is that you get some familiarity with what ANARI is, and understand that the portability and scalability goals of such an API spec would make it hopefully attractive for you. So I think the best place to start is what was the situation that generated the need for a new API standard. And we had the situation with 3D applications on the left and rendering engines on the right. And let's say you're a ParaView developer and you want to say, I want to use Osprey and ProRender and VizRTX. You end up having this problem that you, the application developer, has to learn how to speak to each one of those. Not a terrible problem to solve, but one that has to be solved. The problem is, if someone else, who's another application developer, wants to do the same thing, like Blender, you have to do the same work over and over again, and VMD, and et cetera. Just name your favorite app. You have to solve this problem. And I don't know about you, but that's a mess of lines, and it's only 3 applications and 4 rendering engines, and there's way more than that in our ecosystem. So the goal was to say, can we create an API that applications can talk to that makes all these engines look very similar, and can engines not have to know with who's invoking them to say, if you give me a scene and I can give you pixels, we can enjoy working together. And that's what ANARI is. And in Karen's keynote yesterday on Vulkan, she talked about how Vulkan is not for the faint of heart. I think that was during the Q&A. And so that teed me up to say, ANARI, it's for the faint of heart. So Khronos is a standards consortium that we probably have a lot of familiarity with, and it's been a great way to structure how do you get different companies with different IP to be able to work together on something, on what are the things we can agree on, and then how can we not prevent each other from having our innovation come out. So Khronos has been a great place to participate in a long-standing history of great standards development being done. And so the story of ANARI really starts in 2020. We had an exploratory group before that to kind of generate enough interest around creating it. But in 2020, we launched an official working group. And that was at the point we had to commit to a name. And just so you know, naming's hard. And the acronym ANARI doesn't mean anything, but if you really want it to mean something, I'm trying to campaign for it to mean Anonymous Application Rendering Interface. I hope that catches on. But for now, just accept that that's the name. And we started in 2020, and we quickly moved on to working real hard on the API spec. And so it took a little over a year and a half, or about a year and a half, to get our first 1.0 provisional specification out. But then what I wanted to communicate with this division of path is that every step of the way that we've been working on the specification, there's been software, an SDK that people could use and have it be freely available to get experience with. And so we had an SDK right when the provisional spec came out, and that moved on. We got lots and lots of experience. We talked about what is our story with how do we work with other specifications, like GLTF has some great PBR specifications, and we decided to import those into ANARI. And every step of the way, we kept getting more and more SDK releases to pair with these things. And so that brought us to the 1.0 launch last year. It was a really great time and very satisfying to say we've done all of this work. Now finally in August 2023, we can say we have an official 1.0 spec. And what that means is not that we've solved every problem for how do you connect a rendering engine in an application. What we've done is we've said we think we have the things that we don't want to change in the future, we have those locked down, and we are now much more wide open to what are we going to add to the specification for things that people view are missing. But like I said, every step of the way, still working on that SDK. And then an exciting development this year has been a part of these specifications is what does it mean to be an official adopter of a standard? And so we have an adopters program for ANARI, like there is for other specs like Vulkan, OpenGL. And what that means is if you want to come and say, I'm an official implementer, and you pay a fee, and you get to basically use that brand, ANARI, and have some weight behind your claiming that you implement the spec. That said, if you are not an official adopter, you're absolutely welcome to come and implement the API and ship your implementation. So the idea is the adopters program is a way for us to get some buy-in and some common infrastructure, because it does things like fund our conformance test suite and stuff like that. So that's an open invite to anyone interested in ANARI that consider the adopters program. But Like I said, things continue. We're working on more and more extensions every day. It's part of our 1.1 spec that I'm not sure when will come out, and our SDK, we've had a few releases, continues to mature. So at the end of the day, the cool thing about the ANARI spec and how our working group has been functioning is everything, the spec and the SDK, are all up on GitHub. We're not trying to hide anything from anybody. And so we'd love to have you come participate, but I'll touch on that again near the end. So when you design an API, there's fundamental tensions you have to reason about, trade-offs you make. And the one that you get at this level of abstraction where ANARI sits in the software stack is things that are uniform. So that's where you can get some guarantees of what are concepts that are going to be the same. And then how do you differentiate different features based on what you deem important as a vendor or as an application developer wanting to see, like, why am I choosing to use a particular engine? And so on the API uniformity front, they are fairly mundane topics, but it's important that we not repeat ourselves in incompatible ways over and over again. And that's what ends up happening when we all have our own APIs. The way you create an object, the way you parameterize it, how do you create an array, what's the ownership semantics of that memory, what's the scene hierarchy exactly that you build, how do you deal with concurrency and parallelism, your thread safety, your ability to overlap frames and scene updates. These are all concerns that I think semantically are quite universal, but then in practice we end up doing things ever so slightly differently for very incidental reasons. So ANARI seeks API uniformity on these types of topics, but then on the other side, we want to leave it wide open for feature differentiation. So for instance, the features you decide to implement in an engine is completely up to you. ANARI is not going to get into a debate with a particular engine's features that they deem important or not. What it is, though, is if you have a particular set of features, let's all spell them the same way, is the idea. There's also performance. Performance is a really wide, giant topic, whether you're talking about frame latency, you're talking about scene size, that's technically something else that I called out separately here, but that's performance of memory and like hardware scalability, image quality, illumination, global illumination, all of those things are ways that your engine might be better than others, why you would want someone to use your work. And so how do you balance these two? This is a really tough question to answer. And we think we came up with a pretty good philosophy behind how you can balance these two things. And that's for ANARI to say, you give me the what and the when, but I'm going to let my engine determine how that happens. And so the way that pans out, I think maybe is more obvious if you look at the software stack, which at a very high level looks like this. You have applications who use ANARI. ANARI is interfacing with individual specific engines, and then that's where you're going to talk to graphics APIs and hardware. And so I want to walk through this bottom up from a first-person perspective, because I maintain a backend called VizRTX, and I work at NVIDIA, and so I want to be able to reason about where is all of my software fitting in this hierarchy, or this stack of how I have to deal with all this complexity. And so from my perspective, maintaining VizRTX, I care about GPUs. So VizRTX builds on NVIDIA technology, builds on GPUs. This is hopefully an obvious one. But this is where the next level up is where there's actually a shocking amount of diversity. And I think that's a good thing at least some fundamental level. But I choose optics with VizRTX. You might choose other things in this list. You might choose multiple things in this list. Those are the ways that you get at hardware features ultimately. But what you end up implementing is an entire engine. The ways that you make those pixels from the scenes that you get from your application look like this. And so I come from a scientific visualization background. That's what I do primarily at NVIDIA. So in SciViz, we have 3 different rendering engines that you could take off the shelf and do some really great SciViz with. That's VizRTX, VizGL, and Index. And there's others. Those are all implementations that exist, but that list can be arbitrarily long, and that's one of my hopes in speaking with you today, is I want that list to be as long as it possibly could be. But ultimately, where ANARI comes in is what you're buying into is the way that an application talks to you, not tells you what to do necessarily, but the way it talks to you is fundamentally the same. And so when you think about application architecture, so you have, whether it's a small research app that you're using to show off your research, or you're at a big company with a multi-billion-dollar application, I don't know. The point is that without this separation of concerns, things get very muddy. It's like if you write a 3D application, get ready to start writing Vulkan is a very commonly held presupposition in 3D application development. So what ANARI is doing is saying we can make this split such that you might be someone who doesn't care about implementing a renderer. You might just want to use ANARI and say, listen, I want to offload that work to someone else. And likewise, it could be you have a very specific rendering engine for your problem, and so you might be an application developer and a rendering engine implementer. That doesn't mean ANARI is going to get in your way. Hopefully that helps you organize yourself and then make your application actually more portable. So then this is the whole stack, that not hiding anything. I think this is where there's a tremendous amount of diversity that's good to get a lot of great things, a lot of great research, a lot of great technology. So fundamentally, when you're talking to the ANARI API, it's pretty straightforward. So it's a C99 API, so what you're going to do is you're going to compile against anari.h, which is going to give you a bunch of C prototype functions, and you have the front-end library, libanari, that you're going to link to. You don't have to have runtime loading of backends, but that's what generally people do. And so at runtime, then you can dispatch to whatever renderer you want. At the end of the day, all of those mechanisms are quite flexible. I'm really breezing over those details. Talk to me if this setup's a problem for you, but it's worked really, really well so far. And then just like Vulkan, we took a page from their playbook and decided layering is a good idea. And it turns out when you have an implementation you're talking to, that implementation could be just something in between you and the actual thing making pixels. So then you can do arbitrary things in that layer. And so we have a debug layer that can validate your API usage. Again, very similar to Vulkan, but that already exists today and has been proven quite useful. Okay, so a breeze through the API for how it might look. It's a C API. There's C++ type wrappers. That excites me. If it doesn't excite you, that's okay. The devices are what we call the instance of the rendering engine you're talking to. So this is the core thing, the unit that your application is talking to. And it usually can come from a shared library, but like I said, it doesn't have to. And so we're talking about 2 lines to get your hands on one of these devices. If you're going to load dynamically at runtime, you're going to say ANARI load library, and we have a thing called a library object. And you load that, and that's going to do a dynamic load of a particular library and open it, essentially a DL open. And then you're going to get a device, or multiple devices potentially out of that library. The default's always going to be there, but there's ways for vendors to ship you multiple implementations from one library file. So a very, very core concept in ANARI is objects. I mean, shocker, it's an object model for rendering scenes. So the objects themselves that you have, they're expressed with opaque handles, and that's very intentional to keep implementation detail away from your application. And we have 2 flows of information. Parameters are our word or our term for how information flows into an object, and properties is information that can flow out of an object. And the way this works is it's a transactional semantic where you say, I'm going to set parameters and then commit those parameters on the object, such as in the next frame, those values that are new will take effect. And what this does is a tremendous amount, gives us a lot of robustness for getting performance out of applications, but not having to prescribe very specific implementation details for mechanically how that works. And one note on parameters, that they're unidirectional. So one very quick design trap you can get into is if I can set a value, I want to be able to get the value out. The problem is that getting that same value out is prescribing quite a bit of implementation detail, especially in distributed context or in places you want to throw things on the GPU and not keep things on the CPU. And there's a million things that you could possibly do to want to diversify how you would implement that. So basically, it's like if you set a value, you know what that value is. Keep it around if you really want it, such as displaying it in a user interface. So just to get a flavor for how it looks to interact with objects, when you create some objects don't need a subtype. So like a world is just a world. Some objects do need a subtype, which makes sense. Like you can have a diversity of different cameras. A perspective camera is a very obvious one, but it's pretty straightforward to basically reason about those. Setting parameters, again, I hope is a straightforward concept. This isn't revolutionary necessarily. So you have the device, the implementation you're talking to, the object handle of what you're operating on, the value you're wanting to set, and then the type and a pointer to that local value in your application to set it, where it's going to mem copy from that pointer. And then if you want those to take effect, you simply commit the object and move on. You actually know a shocking amount of the API just from that slide. Now, if you think, of course, we got to build a hierarchy. This is something that, again, should shock nobody, but it's frame-centric. So everything you need to render a frame lives under the frame. And there are some times that you have a single object relationship. Sometimes you create an array of handles. So like a world can have n different instances in it. That makes sense. This is something that I won't walk through every detail of all of these, but again, open the spec and have a look. It should be straightforward to understand. And then what we all came for, rendering a frame. What does that look like? Well, you kick off a render frame with ANARI render frame. I hope we chose that name well. Then you can immediately synchronize with it because that's an asynchronous operation. You don't have to. Then you can map pixels out of a frame channel. You could write that to a file. You could put that on screen, do whatever you want, and then you unmap the frame. So really, you have most of the API's concepts now with these couple of slides. And that's really all you need to make cool pictures, to make interactive pictures, real-time pictures. The idea is the API is not the one responsible for telling you how do you do all that cool emissive materials stuff on those streamlines, animating those. That's all just stuff that the engine's doing for you. That's the whole point. There's a bunch of topics we could get into that I don't have time in a short 25-minute talk. Like, what are all the different subtypes that are available in the spec? What does it look like to add additional ones that aren't yet in the spec? Geometries, materials, samplers, lights, there's tons to talk about. Device introspection is a great topic where you can ask your implementation, hey, what do you implement? Because I may or may not want to use you based on having a particular extension that I care about. The whole asynchronous piece is one I just blew over, but there's a lot of cool application architecture discussions you could have about leveraging that and exploiting that well. What does it look like to have multiple viewports in one app and maintaining all of that either from multiple devices or a single device with multiple frames? Arrays, performance considerations. There's just a lot of things to talk about that we won't be able to get to. But then what I want to give you is a sense of these two opposing forces and how they both can be leveraged really well. And so the first one is that ANARI is portable. So the API uniformity that we get in the things that I say don't matter in terms of diversifying those choices, the things we lock down make it so every time we put ANARI in another application, we get the same story. And like that's the whole point. Like if you want one takeaway of why would I care about ANARI as an application developer or as a rendering engine implementer, it's you implement once, and you can get carried into places that you might not have ever considered simply because you bought into a standard API. And so Blender, we've done some experiments and cool things in Omniverse, ParaView, Visit, VMD. This is just a short list. There's so many more applications that I haven't listed. And one I wanted to point out is there's a lot of little apps we write for our own little renderers when we're doing research, we're doing other application development, maybe I'm developing my renderer. I love Dear MGUI. It's a wonderful UI library. I write apps all the time. That's just a generic ANARI viewport. And even though I made that app to develop VizRTX, I can run any of the other implementations available equally as well. It's a great consequence of buying in to a standard API. But on the other hand, scalability is a very important thing to not lose sight of, because scalability means different things to different people. If you're an offline renderer, scalability means I need to be able to make those pixels as pretty as possible at whatever cost. You could say that scalability is, I want to use as much hardware as I possibly can. Like if you're in an HPC cluster environment like me, you might be wanting to use all of the nodes in that cluster to get as fast and as beautiful pictures as you can. There's different render rates. Like if you're in VR, those render rates are so important to not get sick. Like it's really important. Scene size. There are limits in all kinds of different engines, but ANARI doesn't basically enforce those limits. It's just when your engine's done, it's done. And then of course animation updates. Like that's a whole topic in and of itself that I'm blowing over for the sake of time. But yes, that's something you can choose to be the value that your engine brings in, being able to tolerate animation update rates that are really fast. And so I wanted to tell a really brief anecdote about how research and ANARI can fold together really well. And many of you know know Ingo Wald. He and I go a long way back at Intel and at NVIDIA now. And he wrote a couple of papers on distributed memory path tracing at HPG. 2 years ago, he had a paper on basically ray forwarding based on object hierarchies. That was a cool paper to read. And then also some follow-on work last year about ray queue cycling amongst multiple GPUs and a single node to get all of the memory parallelism or the full memory available to be able to render with. But then there's this renderer that he created called Barney, and it's up on GitHub, and you can go get it today. The problem is, what if you want to put Barney in a bunch of different scientific visualization applications to get it in users' hands, to get access to their content? Like, that's a big problem. And I convinced Ingo to maybe try out ANARI. And so what we did is we looked at this stack, and if we looked at it from Barney's perspective, it looks like this. There are all these applications that use ANARI. Then Barney is the rendering engine. It uses CUDA optics and MPI, and it builds on GPUs and fast network interconnects. And then with that, it was shocking how little work it took to get these production applications with production data sets on hundreds of GPUs sometimes. Like the DNS volume, I think that was 128 GPUs that a colleague just ran it on because it just worked. It was shocking how straightforward it was to get this running in environments that were probably any other way would be really hard. Be a lot of software engineering, a lot of figuring out how to get environments to work. ANARI just made this so easy. It was almost like something has to be wrong. But that was a really cool outcome. And if you want to read details about that whole narrative, we actually wrote a paper on this where it's at LDAV. It got accepted to LDAV this year, but we have a preprint up on ARVIX called Standardized Data Parallel Rendering Using ANARI. And the point is that we were able to take the ANARI API and take its semantics and inject a few extra constraints, no API calls, to be able to have a very tight understanding of every distributed rendering architecture we could think of fit into these semantics such that we could more definitively say, if you implement the ANARI API in a distributed context, there's no need to invent any other interfaces for these applications. They just work. Again, read the paper for more details on that. And so what I want to leave you with are some calls to action, because this is a room full of very bright researchers, some people that have done some amazing work, and there's a lot of discussions about how ANARI could bring you value. The first basic step is just to try out the SDK. Something as simple as get familiar with how the API works. Just try it out. Try out some backends that are up there listed in the README. I'm hoping it's a really straightforward process to just see, make, and voila, you have an ANARI SDK built for you. There's some interesting backends that are available today. There's VisRTX, Osprey. There's a research renderer called Visionary. It's a nice path tracer that Stefan Zellman wrote. We have Ingo's Barney renderer. I have a prototype that works with Cycles renderer out of Blender. There's a lot of exciting work already available today to try out. But the more I guess important thing I would like to implore this room to consider is, if you're sitting on a renderer, as small or as big, you could be doing it just for fun, you could be doing it for big production reasons. I really want you to consider what it would look like for you to look at maybe supporting ANARI as an option for your engine. That's a really big, wide open statement, but one that I think if you start walking towards the benefits of the API stability and the scalability, the differentiation that you want to bring to our ecosystem of 3D graphics is something that if we all simultaneously walk towards, there could be a lot of even more exciting future HPGs. We could be talking about all kinds of great diversity of implementations that everyone could try, that we aren't just holding on to for ourselves. And then actually getting involved with the standard is not actually that bad. If you work for a company that already is a Khronos member, you can just come join the working group. It's as trivial as that. You can see our meeting times, 10 a.m. Pacific on Wednesdays, and we'd love to have you come participate. Even if you just come listen, it's like little half-hour calls. It's not that much overhead. We also have an advisory panel, and what that means is if you're a non-Khronos member, we still want to be able to talk about interesting design decisions with you. And so Khronos has a very well-oiled mechanism for how do we make that happen, so you can still contribute in those kind of design discussions of the API. And then, of course, at the end of the day, if you use the SDK and you don't even talk about the spec itself, and you just use it, and you come up with an issue, we'd love to hear from you on GitHub. And so with that, I'll just wrap up by leaving this up to say I'd love to start a dialogue with you now. Probably don't have a ton of time with questions now. I'd love to talk with you in between other sessions about what ANARI could mean for you. So appreciate your time and would take any questions you have.
Yeah, cool. Yeah, so questions for Jefferson? Oh, yes.
So I'm interested into teaching. Do you think ANARI could play a role in teaching about graphics programming, and how would that be?
Absolutely, for two reasons. One, when you're teaching someone who doesn't have familiarity with hardly anything, it's actually good to lock some things down. To say, you know what, don't worry about designing how parameters get set. Just buy into this and worry about some other things. I think that's a valuable characteristic for teaching. The second is, if you get someone implementing the ANARI API, it's a really strong hook to say, oh my gosh, I just ran it in their Blender add-on and it just worked. And I didn't even have to figure out how Blender worked. Like, that's a really cool outcome to get people hooked on wanting to do stuff. So I think that's a great avenue, for sure. Others?
Did I get it right that Blender already use ANARI for Cycles engine?
So that's technically possible. They're both pretty much in their infancy. So with Cycles, it's pretty much my ability to figure out how Cycles works as like a nights and weekends type thing. I have some people who are interested in wanting to take that into a more production context. Then on the add-on side, that actually is implemented entirely with our Python bindings and using Blender's Python API. I'd love to push that towards a native implementation that lives in Blender. Mm-hmm. And then my hope is if those both mature, then they both basically get to a point with it. You can do everything today, but in that context, but then Cycles is now usable in all these other contexts.
I see. Second question is, does ANARI support multi-GPU configuration of multi-GPU boxes?
Yeah, absolutely, because that's part of the implementation detail of an engine. So for instance, Barney, like it's built to be multi-GPU in multiple ways, and the idea is you would basically ask Barney, what are your device parameters to control all of those things? And then once you have that set up, everything else is identical. So absolutely, yeah.
Hi. In the film and VFX production world, there's universal scene description, which is meant to act as a crossbar, kind of like this. How would you compare?
Yeah, so I'm going to be very careful with my words and very politically correct. Not for the, because I don't want people to get the wrong idea. So we have a Hydra plugin, but the idea of ANARI is it's only about rendering frames. So something like USD is looking to solve a lot of problems, and a lot of problems that ANARI will never try to solve because it's just not the point of the specification of this API. I'd say the closest comparison you could make would be, this would be like the same type of API of talking to a single render delegate in Hydra. So all the scene delegate stuff, still, we have nothing to say there. They're not looking to get into that. It's really, if you're going to talk to a single renderer, you would use an API like this. The rest of USD, not trying to go there at all.
Other question? Yep. Yep, please.
You mentioned that there was a validation layer. How complete is the implementation of that application?
Yeah. So
could you repeat this?
Yeah. To repeat the question, there's a validation layer, and how complete is a validation layer? And validating ANARI has this cool property that we already have built into the API that you can ask your device, what do you implement? And that gives you everything from object subtypes, parameters, their ranges, all those things. And we can actually have the debug layer just ask the device, give me all that information, and now I can validate application use on what the device is reporting. So the debug layer doesn't have to be the sum of everybody's implementation extensions. It can actually be done device for device. So there's already a ton that you can debug that way. We haven't gotten into any like concurrency type validation yet, but most of the problems people have at this high level of abstraction is, did I spell the parameters right? Did I give them values that make sense? Did I make the hierarchy right? And we can validate all those things today. Yeah. So we have very, very rudimentary API replay. I'd love to see that mature like crazy because that's a really valuable tool to have. And I think some challenges we have are going to be in a lot more of the concurrency stuff. That said, the API surface area is a lot smaller. We're solving a much simpler problem to express. So I'm actually hoping the complexity is actually hits a reasonable ceiling at some point.
One last question, so I don't want to hurt your break time. So last question.
Yeah, the question is, it's string-based parameter names. What standardizes that? One is we have core extensions and we have vendor extensions. Core extensions are ones you would look up in the spec and say, I have a perspective camera, and here's the parameters that it can be set on that. And when you ask your device, if you implement the perspective camera extension, that's the subtype and the parameters it can expect. You can get that all at runtime if you want. And the same thing is true with vendor extensions. All a vendor extension is an extension that comes into existence that's not in the Chronos spec. We expect those to exist all over the place. The most important thing is, design-wise, is we didn't want custom things and standard things to look different. And so we didn't want to go we want an API call for everything in the spec, giant API. And then we also wanted to leave things really open for extension. And we found in practice, it doesn't actually trip people up as much as you'd expect. And if it does, we have a debug layer to exactly validate those things.
Okay, thanks, speaker again. So maybe let's break. So please come back.